Hi everyone, I'm Rishabh Khandelwal. I'm from the University of Wisconsin-Madison, and today I'd like to talk about my work on Cookie Enforcer, which is an automated cookie notice analysis and enforcement framework. So we've all had some annoying experience with cookie notices, right? Like mostly because they are hard to navigate. So in fact, in our studies, we find that on average, people require 12 clicks to disable all the unnecessary cookies. This is primarily because web developers use dark patterns, which nudge users towards making website-friendly choices. And in cases when they provide options, these options are not easily accessible to the users. So for example, in the cookie notice shown here, there are about 230 options that the users have to adjust in order to disable all the non-essential cookies. So clearly this is very annoying and not very useful, and mostly helps websites to obtain consent. So to address these issues, we formulate our research objective as how can we enable users to exercise control provided by the websites. And to achieve this, we have 3 tasks. So first, we need to automatically detect cookie notices on the websites. Second, we need to extract fine-grained options for cookie settings. This is challenging because these options are often spread across several views of the cookie notices. And third, we need to understand the cookie options and determine steps to disable non-essential cookies automatically. So here's a brief overview of the cookie enforcer pipeline. It consists of 2 main components, backend and the front end. So backend consists of modules which takes the cookie notice and extract instructions to disable the non-essential cookies and store it in a database. And front end consists of browser extension and an enforcer module, which take the instructions and perform the actions on the user's browser. So before we go into the details, here's a quick demo of Cookie Enforcer. So once the user adjusts their preferences and enable the extension automatically performs the clicks and disables the non-essential cookies. The extension is available on Chrome Store, which you can scan to download. Okay, so let's get into the backend details into the backend component. So starting with the cookie detector, our goal is, given a website, we want to extract cookie notices and its elements. So we first do a web search and get to the homepage of the website, and then we identify candidate elements for cookie notices. Now here, the main challenge is that these notices can be implemented in several different ways, so the HTML signal is not very reliable. So instead, we rely on the rendering process and leverage the fact that cookie notices are present on the top of the page because they are required to ask for consent before processing details. So we specifically use the z-index to identify the candidates, and then we extract the text from these candidates and pass them through a text classifier, which determines whether the given element is a cookie notice or not. Okay, so now that we have the cookie notice, we analyze the notice to extract all the setting options. So to identify the options, we look at all the elements that the users can interact with. These are the elements that users can click or to submit their choices. So we use tabbing to achieve this. But one major challenge here is that some notices have views which are dynamically loaded or hidden settings. So to address this, we interact with each element and click on each element to identify the hidden and dynamic notices. So for example, here, this is the cookie notice for askubuntu.com. And so if we click on the customized settings, we see that there's another view of the cookie notice appears, which has further options. So So finally, we extract the cookie setting text using the assistive technology features. So at this point, we have all the cookie settings and their corresponding text. So now our goal is to automatically determine the steps that are required to disable non-essential cookies. So here we need 2 main components. First, we need to understand what each of these setting element is doing, so their execution role. So there are different execution roles. For example, a checkbox or a slider adjusts your preferences, whereas a submit button enforces the set choices. So we do this by, again, dynamically interacting with the cookie notices and observing the behavior of the notice. For more details about this, please read our paper. And the second component is we need to understand the context of these settings and then determine which elements to click. And there we use natural language understanding. So the idea is that we use a classical language model to determine which elements to click. We pose this task as a sequence-to-sequence task, where we input setting text and which acts as the context for the model to understand. So basically what we do is we take the setting text, we take the setting type, the element type, and whether it is configurable or not, and then we give the sequence to the model and ask it to give us which elements to click. So for example, here we have different options for the same website, and this is the input to the model. So as you can see here, there are like buttons, switches, and switches also contain tags such as not selected or selected, which allow the model to understand that these are configurable options. And then finally, we train the model to output which elements to click. And mind you, all of this was done before the GPT-4 era, so this is using the classical language models. So what happens like now that we have GPT-4-like models, our pipeline actually becomes simpler. We don't need to fine-tune the models now. We can take all the setting options that we have and pass them to the large language models. By doing prompt tuning, we can directly obtain the instructions. So there are two main advantages of doing this is that we don't need fine-tuning, as I said, and these models are fairly large, so they can do complex reasonings, as well as there are no limitations, or well, they can accommodate more setting options in the context. And the main drawback, though, is that very often, like these large language models are behind a paywall, so it can increase the inference cost. Okay, so let's move on to the front end now. So recall that at the end of backend, in the backend process, we store all the instructions into a database. So once the extension is triggered on the user's browser, the database, it retrieves all the instructions to disable cookies for that particular website. And here we also note that we want to make sure that we don't learn about users' browsing patterns. So we retrieve this information in a private, using private information retrieval. So once the browser extension has all the instructions, it dynamically generates the JavaScript code, which looks like that for Ask Ubuntu website. And then it injects the code into the browser and performs the clicks for the users. So the user doesn't have to navigate the notice. The extension does it for them. Now, as different people can have different level of comfort with automation, we provide users with 3 different interface options. The first one is fully automated, where the extension automatically detects the cookie notice and automatically performs the enforcement. So the user doesn't have to do anything. They visit a website, the notice is automatically detected, and the options are enforced. The second option is the semi-automated option, where the users activates the extension, and that triggers the enforcement aspect. And finally, we have the informed enforcement, where the extension first shows all the steps that it is going to take to disable the cookies to the user, and then once it gets the approval from the user, it performs the actions. Okay, so let's now look at the evaluation methodology. So we evaluate Cookie Enforcer with a 3-pronged approach. So first, we perform an end-to-end evaluation on 2,000 websites to see how the system performs. Next, we conduct user studies to understand users' perceptions. And finally, we conduct a scalability study to test whether Cookie Enforcer can work at scale. So in our end-to-end evaluation, we create an evaluation dataset which consists of 2,000 domains, with 1,000 domains having cookie banners. We manually annotate this dataset for each of the components of the pipeline, and then match it with the automated pipeline. And we find that our system works correctly for 93.7% of the cases. More intricate details about this evaluation process is present in the paper. Next, we do user-based evaluation by conducting a within-subject study with 165 participants. Each participant is asked to complete a task, which is disabling non-essential cookies on 4 websites. And each participant is exposed to 4 different interface options, 1 being the manual baseline, and 3 are the interface options for Cookie Enforcer, as I discussed earlier. And as the participants complete the task, we measure the time of completion as a proxy for a user effort. And we also have an usability score, a usability survey for each interface option. So looking at the results, we see that users find the cookie enforcer interfaces more usable. Those are on the right one, the manual one is on the left. We also noticed that the time taken to complete the task is lower for cookie enforcer interfaces than for the manual enforcement, with it being lowest for fully automated enforcement, which is to be expected because user doesn't have to do anything. And finally, we performed the scalability analysis, where with 100,000 domains from UK. And here we find that we detect cookie notices on about 53% of the websites, which is consistent with what manual analysis has found. And we also find that about 36 or 35% of the notices have multiple views, and with average number of settings in these cases being like 28, which is very high. And we also see that only 21% of the websites provide one-click opt-out options, which is not great. Yeah, in conclusion, we present Cookie Enforcer, which automatically takes cookie notices, analyzes them, and determines what steps to take to disable the non-essential cookies. And thank you. I'll be happy to take any questions.